Okay, so section 8.1, this is the introduction to trig. Okay, so this is the beginning of what is coming to you in pre-calculus and in calculus if you're going to move on to a science major. So one of the acronyms that you have to remember, that I recommend that you remember, is SOHCAHTOA. Okay, so SOHCAHTOA, it's S-O-H, and then is C-A-H, and then is T-O-A. SOHCAHTOA. Okay? And what that stands for is whenever they ask you to get the sine, the cosine, and the tangent of an angle, those three trig properties allow you to get the ratio of two sides. Okay, so in triangles, like we study first semester, you know how you use a 30, 60, 90 and you find a missing side, and then you use the Pythagorean theorem and you find, the missing side, whatever missing side, that you have. They give you two in the Pythagorean, you find the third one. In the 30, 60, 90, 45, 45, 90, they only give you one measurement and you have to find the other two. Well, here, they might give you the measurement of the angle not being 30, not being 60, not being 45. So if it's not a special triangle, if it's a measurement other than 30, 60, 90, or 30, 60, and 45, then we have to use SOHCAHTOA. Okay? So stands for sine equals, this is sine, let me put here sine, S-I-N-E. And sine is just the opposite side over the hypotenuse. And then cosine stands for C-O-S-I-N-E. That's how you spell cosine. And you abbreviate cosine as C-O-S. And cosine is a ratio of the adjacent side over the hypotenuse. Then TOA, it's tangent. That is for tangent. T-A-N-G-E-N-T, tangent. And tangent, you abbreviate it as T-A-N, and that is the opposite side over the adjacent side. Okay? So what we do is we're gonna be given a triangle, okay? And you have to determine which is the angle that is given. Sometimes the angle is gonna be at the top, like in this case, this is the angle given, right here, it's at the top. And over here, the angle is on the base. So wherever the angle is, you have to look for the angle that you need to find that trig function for, and then label the triangle. Like for example, here. From theta, by the way, that circle is called theta, T-H-E-T-A, that's theta, it's a Greek letter, okay? So theta is the angle, and this is the opposite, so this is the O. Across from the right angle, you always find what side of the triangle? The hypotenuse. And right next to theta, it's the adjacent, okay? So this is the adjacent because it's adjacent to that angle. This is the hypotenuse because it's across from the right angle. And this angle is across from the opposite side. So the angle is across from the opposite side. This is the opposite side. So if I look at the second triangle where the angle is on the base, God bless you, across from theta is what letter? The opposite, so is the O. Across from the right angle is what letter? Is H for the hypotenuse. And right next to theta, that would be what? A, the adjacent. Okay, so we label the triangle like that. Now, let's go ahead and go with a guided practice. Let's see. First of all, you have to look at the trig function that they're asking you. Here, they want me to find sine of j. Okay, so first of all, the angle that I need to refer to is j. The angle is j, okay? So from angle j, so here's angle j, I need to label the triangle first. Okay, so let's label it from j. Across from the angle j, what letter should I put on that? The O, because that's the opposite. Now across on the right angle, that should be what? The H. And right next to J, that should be what? The A. Okay, so you label your triangle first. Now that you label your triangle, then follow SOHCAHTOA. Okay, they want sine. Let me just put here the acronym: SOH, CAH, and it's TOA, SOHCAHTOA. Okay, now since they want me to find sine of J, look at the ratio. Sine is what over what? Opposite. Over the hypotenuse. So let me get the opposite side to J, which is 60, and the hypotenuse, which is 61. Then can you reduce it? No, we cannot reduce it, so we just leave it like that. Okay, next. Then they want cosine. Come on, pick it up. On cosine, it's CAH. So I need the adjacent side. So the adjacent is, what's the length of the adjacent? 11. So it's 11 divided by the hypotenuse, which is 61. Okay. So can you reduce that? No, we cannot. We'll just leave it like that. Next, tangent. So tangent is the opposite. So what is the opposite length? 60. So it would be 60 over the adjacent, which is 11. Can you reduce that? No, just leave it as an improper fraction and just leave it like that. Okay? Now you go ahead and give me sine, cosine, and tangent from K. So in that case, you have to go back and you have to erase those letters. I cannot erase it, but you go ahead and erase it. You can draw it again also, yes. You can draw it again. Okay, so person number 13, lucky 13, who's that? You? Okay, so Aaron, what do you describe as the pattern from the above? Okay, tangent of J and tangent of K are flipped around? Okay, good. That is right. How about person number 12? Rigo? Anything else that you noticed that happened, Rigo? Cosine and sine, you mean cosine of J and sine of K are the same. That is right. And the other way around also, yes. Sine of J and cosine of K are the same thing, yes. Because those two properties, sine and cosine, are complements of each other. So sine, for example, of 30 is cosine of 60. And sine of 60 is cosine of 30 because they're complements of each other. And we can check that by doing problem number 8. Okay, let's go ahead and add one more problem here. Problem number 8. Problem number 8, we're going to draw a triangle. We're going to pretend we don't know the angle. The letters here are going to be A, B, and C. The measurements are going to be 6 is the short leg. This is 6 square root of 3. What do you think is AB? 12. Yes. Okay. So when I get my sine of A is what? Okay, well, sine of A is what goes first with sine? Opposite, which is 6, over the hypotenuse, because it's so katoa, so it's 12. And you reduce that, and that is by 6 is 1. By 6 is 2, so it's 1/2, okay. And then let's get cosine. Cosine of B. So cosine of B, what are the letters that you use for cosine? Adjacent over the hypotenuse, okay. So then the adjacent is 6 square root of 3 over the hypotenuse, which is 12. Can you reduce that a little? Yes, the 6 and the 12 again is 1/2. So this is just like square root of 3 over 2. Okay. And then we get a tangent. Okay. Now, I made a mistake. Do you notice that I made a mistake?
No. Is it like the cosine of B? Isn't it like 6?
Mm-hmm.
Instead of 6 square root of 3?
That is right, yes. See here, it's 6. Why is that 6? Because I'm referring the cosine from angle B. So from angle B, the adjacent is 6 over the hypotenuse, which is 12, and that is 1/2. And that's what I was just mentioning in the conclusion, that sine and cosine are complements of each other. They add up to 90. So whatever sine of A is of the first angle, that's going to be the same answer as cosine of the complement of that. So it's 1/2, 1/2. Okay? So if I were to get, let me go back and get sine. Now let me get sine of B.
So it does matter.
Which angle
Yeah.
you're using, yes.
So we're not doing 10?
We're going to do that in a little while at the end. Okay, so sine of B. Okay, so sine is what over what?
Opposite over hypotenuse.
Opposite over the hypotenuse. So it's opposite over the hypotenuse. So I have to look at B. The opposite is 6 square root of 3 over hypotenuse, which is 12. And then you can reduce that, right? That would be square root of 3 over 2. Great. Now let me get the complement of that, which is going to be cosine of what? Cosine of A. If I get cosine of A, okay, now this is the angle that I need to be using. Okay, so cosine of A, adjacent would be what? 6 square root of 3. Okay, so it's 6 square root of 3 over the hypotenuse, which is
12.
12, right? Hypotenuse is the same all the time, so it's 12. And now we reduce that, and that is, again, square root of 3 over 2. So notice that sine of B and cosine of A are complements of each other, and they're exactly the same thing. Okay? So now, let's go ahead and get the last part, which is tangent of A and tangent of B. So let's get tangent of A first. Okay, so tangent of A, from A, tangent is opposite over what?
Adjacent.
Adjacent. So opposite, how much is the opposite side? 6 over the adjacent, which is
6 square root of 3.
6 square root of 3. Okay, first of all, let's reduce this. Can we simplify something?
6 6.
The sixes, right? We can just simplify the sixes, and that's going to be 1 over 1 square root of 3, or just square root of 3. Now let's go back to see if you learned what you were supposed to for semester. Can you leave the fraction like that?
No, we distribute.
No, we cannot leave radicals on the denominator.
Yeah,
So what do we do then?
distribute the radical.
You mean
Or the-
rationalize?
Yeah.
Let's rationalize the denominator, multiply top and bottom by square root of 3. And then 1 times square root of 3 is just square root of 3. Square root of 3 times the square root of 3 is square root of 9. And square root of 9 is 3. So tangent of A is the square root of 3 over 3. Now let me get tangent of B. Okay, so now from tangent of B, I have to look at the B angle, and I need opposite over adjacent. Okay, so what is the length of the opposite side from B? 6 square root of 3,
6.
and the adjacent
6.
is 6. Can we reduce that?
Yes.
Yes, that's just 1, so it would be square root of 3. So here, tangent of B is just square root of 3. So if you look at this here, this is tangent of A without being simplified. And this is tangent of B. Okay, so look at this too. The first one that is not rationalized, because when you rationalize, you get this answer. But without being rationalized, do you see that this is the reciprocal of this? You see that? They just flip around. So yes, tangent of A and tangent of B, A and B complements, they're always going to flip around.
Always?
Always. Okay, so those two always just flip around.
But the hypotenuse stays the same, right?
But with sine and cosine, the hypotenuse, whatever that number is, it stays the same, okay? So for sine and cosine, the complement is going to be always the same. So sine of 30 is the same thing as cosine of 60, because that's a complement, okay? So any questions about the quick lesson? Yes. Tan of A, tangent of A?
Yeah.
It's without being rationalized, tangent of A is this part.
Oh, so that would be the right.
That is without being rationalized.
Versus
But you need to rationalize it and don't leave radicals on the bottom, so they will be the final answer. But without being rationalized, these two are reciprocals of each other, like Aaron was saying. That was, flipped around, yes. Any question? Any other question?